Find the dimension of the subspace H of R2 spanned by the vectors 1, -3, -1, 3, and -2, 6. So just to get us started, let's label these vectors. I got v sub 1, v sub 2, v sub 3. So just in looking at this set of vectors here, we can immediately see that this is linearly dependent. How? Well, since the number of vectors, which is 3, is greater than the number of entries per vector, which is 2, this tells us that a free variable must exist. And so the set of vectors are linearly dependent. So this lets us know we've got to find some sort of linear dependence relationship. We want to go ahead and apply that spanning set theorem and remove the redundant vectors. So we again are looking for linear dependence relations amongst these vectors. And so what I'm about to do is not necessarily an exclusive solution. You always want to look at the set of given vectors and identify what do you see first, right? It might not be the same thing that I see. But when I look at this, I realize, wait a second, v sub 2 is equal to -1 times vector v sub 1. And we can confirm this to ourselves by thinking about the components. We have the vector -1, 3 is equal to the scalar multiple -1 multiplied by the vector 1, -3. So v sub 2, vector v sub 2 is redundant. We can also see that vector v sub 3 is another scalar multiple. We have -2 multiplied by that vector v sub 1. And we can confirm this to ourselves. Looking at these components, I have -2, 6. The vector -2, 6 is equal to the scalar multiple -2 multiplied by that vector 1 minus 3. So what this is letting us know is that v sub 2 and v sub 3 are redundant. So we can remove these two vectors by the spanning set theorem to attain a linearly independent set. So by that spanning set theorem, we can remove the redundant vectors, v sub 2 and v sub 3, and the set v sub 1 defined by that vector 1, -3 will still span the space. So this still spans H. Woohoo! And since the set has one vector, it's automatically linearly independent. Need a little more room here. So since only one vector exists in the set, it is linearly independent. So we have confirmed the two definitions of our bases. We have that this set spans the subspace and it's linearly independent. So we can make our final conclusions. We can say that therefore, the basis for our subspace H is that set containing the single vector we just found, v sub 1. And since one vector exists in this set, the dimension of our subspace H is 1. And so this is our beautiful final answer.